everyone, and welcome back to another edition of Index Office Hours. Today is the 8th of October, and this is Index Office Hours 178. If anyone is new to Index Office Hours, this is the town square where graph ecosystem participants come together and discuss the most important and relevant topics for indexers. We had a few new indexers come over the past couple of weeks, which is great. We love to see that. Hopefully more and more people will join and get value from this conversation. As always, this is a conversation. We love participation. So if you'd like to get involved in today's conversation, please do via the text box in the corner or by unmuting your mic. And if you're having any challenges there, let me know and I will get that sorted for you. As a reminder, this is going to be recorded and posted onto public channels like YouTube. So if you are concerned about privacy, please bear that in mind. And with that, let's get into today's exciting agenda. So as always, I give a shout out to the latest 𝗨𝗀𝗂𝗧𝗧 episode, and today is no different. We've got episode 189. Holy moly, that's so many episodes. We're almost at the 200 mark. I know we acknowledged that last week, but it's always lovely to celebrate the progress that Nick has made and the consistency for which he puts out these episodes, which is commendable. So it's with oh gosh, I'm gonna butcher this. I'm gonna, you know what, before I even try to attempt the name, please give me the like the pronunciation. HQ. Okay, thank God. Thank you, Nick. You saved me a ton of embarrassment there before trying that. So we had HQ on the episode, and HQ is the co-founder and chief operating officer of DSRV, which is a blockchain infrastructure provider in South Korea, and they are doing they offer a bunch of different services for 50 different protocols, blockchain RPC services, development services, that kind of stuff. And if you're interested to learn about his journey growing up in Seoul, moving to Canada, his research experience in university, and of course some of the stuff that he's doing in the Web3 space and how he his kind of thesis on the graph and how it plays a role in the work that he does, then do check out the episode as always. And an indexer of the graph. Thank you, Nick, for the addition there. Of course, a very important aspect of the work that he does in Web3. So appreciate you flagging that. Go do check out the episode. Juan has so kindly linked the episode there. Do check it out. And thanks again, Nick, for helping me out there. You saved me a whole heap of embarrassment. So we love you. We appreciate you. Okay, wonderful. Let's go on into the Repo Watch section of today's conversation. So Anna, without further ado, take it away.
Thank you, Abel. Hello, everyone. Okay, so Repo Watch, starting with execution layer clients. We have had a new alpha release for 𝗨𝗀𝗀𝗧𝗧 for version 3. So this is 3.0.0 alpha 4. This is only worth mentioning because it comes with a breaking change. The breaking change relates to using different ports for pPorf, metrics port, and diagnostic port that before were conflicting in 𝗨𝗀𝗀𝗧𝗧 2. So just so you're aware. Then we have had a new Nethermind release. This is version 129.0. Also includes a breaking change with the replacement of Discovery Disk5 enabled flag to be a more generic Discovery version flag. And this defaults to V2, but also allow for V5 discovery. And then this release also comes with some memory optimizations and additional performance improvements in block validation. Next release is from Hangdao. This is version 1.0.9, which includes several improvements and bug fixes. Some of them are handling account sequence in the bridge, adding a status endpoint for Tendermint, and increasing max limit for the list span API. This is all we have from the execution layer client. On the consensus layer clients, this week we have a new Teku release, so version 24.10.0, which introduces blob handling and networking improvements. and it also introduces support for the ephemery testnet. This release also comes with fix for a CVE, so security improvement as well. So make sure you do upgrade to this release if you're using 𝗨𝘀𝗃𝗀. And on the graph stack, we have a new release from Indexer agent and service. This is for the TypeScript version of Indexer. It's a performance fix that removes a workaround where we had to query the graph node for indexing status twice to determine a deployment state. And it also moves flash outstanding receipts to use a read committed isolation level. This release is 0.21.4-4, so worthy mentioning here that the release naming has changed. And this is all we have for this week. Yeah, over to you, Juan.
Thanks, Anna. Okay, getting into Protocol Watch, first of all, we have for forum governance, request for information about disputes GDR 17. This was an ongoing GDR dispute. As far as I could tell, it hasn't been yet closed, but it has been confirmed that it's going to be essentially closed as a slash and a draw. As far as I'm aware, I think there were two disputes at the same time. One is going to be a slash, the other one's going to be a draw. But I don't think the transactions have gone through yet. But that's the latest on that forum post. For forum research, we don't have new updates. For the contracts repository, we do have a bunch of Graph Horizon subgraph service updates. A few of last week's PRs have been merged, and a few others have been created. But yeah, there's an ongoing effort to get Horizon, done as soon as possible. Not sure. Cool. The transactions just went through. This has been confirmed in the chat. Cool. So that's it for contract repository, and for the network subgraphs, we don't have new updates since last IOH. So that's pretty much it for Protocol Watch. I don't know if Paka is around, so I'm gonna hand over to 𝗨𝗀𝗀 now.
Amazing. Thank you very much. Yeah, Packet isn't around, so we're going to go straight into the open discussion. And today we're fortunate to have the GraphOps team, and they will be leading a session on the Firehose chart and sharing some insights. And I believe Carlos will be leading the presentation, and then Anna will be supporting as well. So without further ado, Carlos, feel free to take it away.
All right. Hello, everyone. Give me just a second to share the screen again.
Hello.
Okay, so we're going to present again with a focus on the Firehose chart that we've been working on in bringing Firehose support to Launchpad. And the agenda is going to be, as I'm aware, a lot of you guys are not that familiar with Kubernetes, and maybe not so much with Helm charts consequentially as well. There's going to be a very short, more of a conceptual introduction about it, but it kind of only makes sense, or it leans on assuming a lot of you guys have some experience with Docker containers. And if not, then it's really a lot of ground to cover. And then, so we're going to talk about those bits of the stack, short intro, and the Launchpad chart support for Firehose. We're going to demo its usage for a little bit, and also talk about a very overview of the rest of the Launchpad stack, and there'll be a Q&A section at the end. But please feel free to interrupt at any moment. And just a second. So, starting with Kubernetes, this should be in presenting mode, but it's not. Okay, now it is. So if you're at all familiar with running containers, Kubernetes is the container orchestrator, which if you've been running containers, probably use Docker Compose. And the basic idea is that you want to launch a lot of containers, you want to update their configurations, and you want to keep them running even if they crash. Maybe you want to scale them to run like a lot of them as backends with some load balancer on top. And Kubernetes targets that kind of use case. So how to really scale up the usage of containers as a delivery mechanism for workloads, delivery and deployment. And so it's built for very large, for large scale, for supporting large scale environments and production environments. It abstracts a lot of the infrastructure. When you run any kind of application, you kind of need resources from the infrastructure that it's going to consume. These are things like where it's going to store its data, how it's going to connect to the outside world or accept connections from the outside world. And just a bunch of those are operating system level configurations for its own containers in terms of security. So Kubernetes offers a lot of abstractions on top of those and represents them with a lot of resource types, which are just schemas or specs, where you specify the preferences for all of those. And we'll see a short example of that in a second. And other than that, it's API driven, so you kind of mutate or you add those resources with API calls. Of course, there's tools to do so, but it's API driven. You declaratively specify what you want, what your workloads are going to run, how they're going to run. And then it works on reconciliation loops, which means it always tries to drive the state of the system to what's been specified. So if you change the specification, it kind of executes those changes. If something happens and something is crashing, it will keep endeavoring to try to set it running as it was. That's the gist of it, at least the part that interested us. And so let's very quickly, just to make it a bit less abstract, look at what those resources look like. So if you have a Kubernetes cluster, and you're going to be creating, say, a configuration map, which is basically just a text file or like a container of key value pairs. And here as an example, I'm specifying I want to create a config map. There's a bunch of metadata I can add, like naming something, I can add labels, and then given it's a config map, it has a key and it has a value, and in this case, I'm just storing the JSON configuration for my workload here. And this will be a Kubernetes resource. All of this is specs, and it's very YAML based. As another example, we'll have like a service here. Again, same kind of pattern, the kind it is, the name, and the labels. There's a different specification though, because it's a different kind of resource. It will have ports and target ports because this is an abstraction for communicating with the container. So it will be kind of like exposing ports in a Docker container. And it's basically a layer for load balancing. That's why it has a different target port and a selector, which will basically target multiple backends that have this set of labels. And then the deployment, which will be the thing that will actually run your workload. This spec has a lot more fields to it. It will have the same kind of standard ones as a name, labels, all of that, and the ones you would expect to actually configure your workloads. You can pass arguments in a container, volume mounts and volumes for storage configuration, volume claim templates, and all those sorts of things. I'm not going to get deep into this. It's just to make it a bit more concrete what a resource is. So I'm going to go back here now, which I need to do like this. So that's Kubernetes, and you have your cluster, and then you're going to have a bunch of these resources. And if you take a set of these resources, that's going to represent an application that you want to be running on your cluster. And because an application will have the container with the workloads, it will have maybe resources that represented storage or config maps or services and all sorts of those kinds of resources. So for a given workload deployment, you're going to have not one, but kind of like a bunch of them. And Helm is a tool to bundle those resource types and kind of like package them. So it's you can think of it as similarly to a package manager because it's mostly responsible for the lifecycle management of deploying these packages, which it calls shards. And it's focusing on lifecycle management, but your workloads will need configuration, and it also has another capability, which is to template the resources it's deploying, so that it gives you some flexibility in terms of either changing them in terms of the shape of the deployment architecture, or what's deployed or not, or actually configuring your workload. For instance, by allowing you to easily template the arguments that's going to be executed on the container, as an example. So this is the role of Helm. It offers a bit of a package manager to deploy workloads into a Kubernetes cluster. And we can very quickly look at a Helm chart, a simple one, like this one is a bit simple. So it has a directory of templates for those various resources. This is going to template to something like the examples of the resource types, but it has basically templating here to make it dynamic and to be configurable and flexible. So here we have a service monitor, which is another kind of resource, and we have a deployment, kind of like the example we saw. And this is the gist of a Helm chart. It's going to generate resources to be deployed in lifecycle management, in the lifecycle management of them, deploying, upgrading, and installing, also part of it. So back to it. Before we start on firehose, any questions on this part? I would assume not. Maybe I missed something on the chat.
Yeah, I was just going to say, feel free to type in the chat or unmute the mic if you have any questions you'd like to share or ask. Sorry.
Yes, it's easier for me if you actually say something, but I'll try to pay attention to the chat as well. Okay, so I know you. Go ahead.
So yeah, just don't worry about the chat. I'll keep an eye on the chat and put a question mark under anyone's questions, and then direct your attention to that whenever you pause. So don't worry about the chat. Just feel free to go into the flow. Yeah.
Thank you. Next will be firehose, and I know a lot of you already seen quite a bit about firehose, so I'm not going to cover any of that. I'm going to focus on how it's been currently being packaged and delivered, and the challenges in making a chart for firehose. Yes, the first bullet point you should all be aware, it's built for scalability. It follows kind of a microservice architecture for interfacing protocols. And one of the components that's the most problematic is the one that extracts data from the blockchain by instrumentalizing it. And that's most problematic because it's the component that's the most chain specific. So it's where you'll find the most variation between running firehose for, say, Ethereum mainnet, or for Arbitrum, or for Solana, or something else. This one is going to be the most standardized one. So this component, which is ingesting the data from the nodes, the chains nodes often is going to be running the node itself, an instrumentalized version of the nodes, which means the node will be outputting data that firehose is going to read, and is going to be launching itself, which justifies a bit why the configuration aspect is a bit more chain specific, because you're also going to be having to configure the node, the chains node that's going to run. And they release, Streaming Fast releases a bunch of these connectors, which are chain specific, but for instance, firehose Ethereum kind of covers or has a lot of common ground with all EVM-based chains, so Arbitrum, Polygon, all of those, Ethereum. And there's a bunch of others, like Firehose Near, Firehose Gear, Solana, Starknet, kind of get the idea. And the first chart we did is going to be targeting Firehose Ethereum, so that will be focused on all EVM-based chains, and not any of the others yet. Other than that, is there any doubts regarding Firehose at this point? Okay, so one of the challenges here is that if we want the chart to support multiple chains, we're going to have to run different images, which is a bit of an anti-pattern and complicated, given that one of the primary goals of a Helm chart is to do lifecycle management, and for that, kind of should be tied to a specific image. But there are a lot of chains, and we have as starting goals, we would like to have support for a broad range of them, and it is not. We want the support to be very flexible. So those are kind of setting our initial goals. The challenges there is the different container images requirement, which is basically different tags that StreamingFX puts out. Say one specific for Arbitrum Nitro, one for any of the other chains. Given this workload needs to configure the chains nodes, configuration also varies quite a bit. And Firehose itself, the architecture, involves quite a few components, and there's quite a few different ways that people might like to deploy them and to serve different use cases. So there's really a lot of flexibility required. And the point of this presentation was to introduce you guys to the chart we have available as a canary release, which would be what we're going to be focusing on. It is meant to address these goals in terms of it's meant to be used to support all the Firehose EVM chains. It has attained a very flexible, it's attained a lot of flexibility in terms of the ways it can deploy Firehose. And we'll move on for that. So the high-level overview of this chart, and some of this may be a bit familiar if you are familiar with the graph node chart, but there will be a section configuration to specify the components we want to deploy. And those components will be like the reader node or the Firehose gRPC server or the merger, etc. And this is where we'll have the most flexibility to shape the deployment architecture the chart is going to deploy. So if you want a pod, which is the unit, the Kubernetes unit for a set of containers, like an individual block, if you want the pod to be running all of the services at once, that's where you would actually do that kind of setting. Or if you want them separated, and you want several replicas of one component, less replicas of another, you will handle that kind of deployment architecture in this section. Then we have Firehose service defaults, which allows us to set Firehose, allow us to set defaults for each Firehose service, where a service is those Firehose components, like the reader node, the merger I was talking about, etc. And then we have a section for defaults that will be inherited by everything. So this would be slightly familiar for anyone who's used the graph node chart, which also allows you to specify graph node groups and kind of have a lot of flexibility in terms of the shape of the deployment. Another noteworthy addition is that the chart will support templating on the values, which enables enables the user to do configuration management, which is tied to some source of truth parameters. So instead of having to repeat parameters, you can actually in the values, use templating to point at some other parameter or make conditionals. That on a Helm chart is traditionally done ties with the resource templating, but we went a different way for reasons we'll talk about next. And there's a lot of flexibility. You should be able to override anything anywhere on the resulting resources. And there's quite a bunch of configuration interfaces that we'll go over that bring common usage or facilitate common usage and other added value features. So let's take a look at the chart, which is what we are here to do. And are there any questions here? I see there's a bit of chat here.
Yeah, not so much in the way of questions, but people seem to be talking amongst themselves. So,
Okay.
yeah.
All right.
But if anyone has any questions, fire away. As always, we will happy to answer. But in the meantime, yeah, feel free to keep flowing.
Yes, I'm going to use Helm to install a chart with a default set of values. And I'm going to start with Ethereum. And this basic command line should be Helm install. I pick a namespace, which is kind of a virtualization layer in Kubernetes. You don't need to pay a lot of attention to it. I'm going to name it Firehose it to my deployment, which is this bundle of resources going to get deployed. We'll have a release name and a lot of metadata like versions and etc. I'm going to be using a chart, and I'm going to give it this values file, which we'll look at next. I'm just going to go over how to do an initial deployment first. Now, because of the templating and other reasons and the complexity of this chart, this actually takes a bit. For those of you who've used Helm before, it might be you may be used to it being quite a bit quicker, like 2 or 3 seconds. This is going to take about 27 seconds or 25, something like that. But it's done. And if I go to get my resources deployed on the namespace I was using, which is AOH Firehose, I see there's already a lot of things going on there. So I need to wait for a little bit, try to settle, because I had actually a previous deployment that I need to uninstall right now. So it is AOH Firehose. I can list the releases I have in this namespace, and I'm going to install a different one that was there, which is not what we're deploying now. To clean it up a bit. And we can focus on what's left now. So it created for us, if I get all the pods, each pod is going to be running a container running Firehose, different components in this case, and I have an instance for gRPC, index builder, merger, wither node, and relayer. They're all running. I can actually get the logs of what's going on in these containers. In this case, the wither nodes. Which has booted, and it has launched the Ethereum node, which is get, and it's on the peer, but it's now looking for peers, and should be good to go. So let's take a look at the value which deploys it. And there's some labels here. Now this is the Firehose components section, which is, like I said, where we will shape the deployment architecture. And there's a list on this map of, there's a map here which has a wither node, a gRPC component, a relayer, a merger, and an index builder. This kind of corresponds to what gets deployed. In terms of pods, I have one of each of those, and they're running. So if I wanted to change that, and we will change that in a second, I will come here. Then the Firehouse component default, which we talked about, and here I'm setting the image I'm going to use, which actually for this chart is intended to be this one, Firehouse Ethereum. It's just a tag that is very chain specific. So this tag right here is to run Git. There's a specific version for it, and there's some other parameters. Now we have a Fire8 section, which is where we'll configure our workloads. There's a couple of parameters here for metrics, peer-to-peer, JWT. We'll talk about this in a second. Then there's a configuration section where we pass some common configurations. In this case, this values file is setting up Firehose to use a pre-existing bucket that I created ahead of time. And this bit of setup is going to be setting for all the Firehose pods these URLs. It's setting a data tier to use. It's going to create a config map. We want that. Again, because of the choice of using object storage, which is highly recommended, I'm also enabling an init container that the chart has available to be used, which will do environment var substitution on the config map, which will be used for configuration. Given that I'm using a bucket, I'm fetching secrets from a secret, and I want those to be replaced on the configuration. I'm adding a few more environmental variables, also related to supporting the bucket. And then we have the Firehose service defaults. Now this section is it will be the most lengthy one. This is where you would want to tune configurations per service type. So if you want to configure all of your reader node components with common settings, you would go to this section here, Firehose service defaults with a node. And this one tends to be more lengthy because it will have also the configuration for the chains node. And that chain node is one of the things that varies the most between chains. So it will involve the most work, or the biggest diff between one chain and another will probably be around this section. So we have a config here for the reader node configurations, node metrics, and node arguments. On node arguments, we have basically Git parameters. This chart has a very neat kind of user experience functionality, which is this will be translated into command line arguments for the workload. But we've, in general, went with the choice of building a map, and this will be templated into command line arguments from the maps options. And because it's so common to have a common prefix on options like dash dash, data tier, dash dash, Firehose enable, we had a bit of functionality to shape how this is going to be translated into command line arguments. In this case, this will generate dash dash data tier equals that value and so on. With some other functionalities like this one, HTTP, with a special none value here, just means it will convert to HTTP, no value. Okay, so showing its usage. I deployed it, it was running, now it's running for 6 minutes. Let me see if something a bit more interesting happened in the pause. It is still not generating blocks, I don't think. Oh, it's not going to generate blocks because it is Ethereum, and it's going to need a consensus layer node to actually work.
Just pausing here, Carlos, just because Vince was asking if it would be beneficial to add a consensus client chart, and I guess this is a good time to just address that. So the question is if it's beneficial to add the consensus client chart as a dependency. And I mentioned that we don't have a strict dependency at the chart level.
Yes.
But we do, we can add this as a default in the namespaces level. So just wondering if you have anything to add there.
It's basically that. I'll just mention that we do have consensus layer charts, and you can use our set of charts, which is Launchpad charts, to deploy consensus layer as well along with this. So I could have a values file here for a consensus layer chart, and I will install it alongside it one on the same namespace. The thing is, Helm works at chart level, and when you deploy interconnected, like the consensus layer is going to be very related to this workload, right? They need to be configured in a very aligned way, and that you can't really easily do in independent charts. So that would kind of force you to add the chart as a dependency and build this Helm charts which have a lot of dependencies, and that has quite a few drawbacks. So in Launchpad, what we decided to go with is we keep charts close to the workload they're about, and we want to offer a lot of flexibility in terms of being able to configure them, and we want to keep all the configuration management inside the scope of that chart. For grouping charts together that make sense to go together, or like functionally dependent or logically connected, we have Launchpad namespaces, which sole purpose is to address that on an upper layer. So it bundles Helm charts together. We will have, it's not released yet, but we'll have a namespace for Firehose, and it will bring along the consensus layer. And it focuses also on doing configuration management across the charts, because you're going to want to have, like, say, if it is a JWT to communicate, you're going to want to have a shared JWT between the execution layer and the consensus layer. You want them to be pointing at each other, and all of that kind of configuration management of them. Does this address the point? I think so.
I think
Yes.
so too.
Yeah, our Ethereum namespace also bundles proximity, as Anna was saying. Our actually namespaces have some quite complex namespaces, especially the platform level ones, like the monitoring one, which is intending to deploy whole observability stack. That packs in quite a few things and a lot of configuration. So back to the chart, I'm just going to quickly uninstall this deployment, change the values a bit, and showcase its flexibility in doing so. What did I call this release? See what's deployed. I'm going to install this. Give it a second. Notice what's installed now. It's only the bucket related things I had created ahead of time. And I'm going to reshape my components. So instead of having a reader node, gRPC, the layer merger, and index builder, I'm going to rename this one to be called maybe TwicePad. And it's going to have the reader nodes, it's going to have the merger, and what else? And I'll bundle in the index builder on it. But it's a list of the services that Firehose is going to execute on this particular pod. And now I want the same pod to be running, to be launching the 3 services in one. So I'm going to remove them from here. Not remove them, I'm actually going to disable them. because they're part of the chart's defaults. So I'm going to just set enable to false, and I'm going to also set enable to false on the reader node 1, which I also deleted. So I should be left with one called bypass, a gRPC one in every layer. I'm gonna call this with path now, and I'm going to disable with this one. I'm gonna have the layer here, disable it in here. And if I deploy this now, I should actually only have 2 pods, and they should be running multiple services on the same one. All these deploys, I'm going to talk a bit about why did you went with this kind of approach. Some of the challenges there. We were intending on deploying quite a lot, on supporting quite a lot of chains in the future, and it's really not maintainable, does not feel very well. So to have one independent shard per chain, when we know there's people running 70 or 100 chains. And there's quite a lot of repetition among them as well. The templating bit serves 2 purposes. It kind of gives us a lot of transparency, because in the way this is usually approached in Helm charts, the templating gets mixed in with generating the resources, and that's a bit out of the view from the values file, which is really what the user cares about. So the charts behavior supply now becomes a little bit more hidden or obscure in that sense. So if this is not very long. Let's see what I have going on there. There we go. Now this deployment has only 2 pods, and I will name them the read path 1 and the write path 1. And I can see what's going on here. I see the pod is running. And if I open the shell on this pod, you can do this. Not what I need. Okay, I should be able to see what is running here inside the container. Now it's running file. It starts with the config file, and this config file has here the list of the services I want to launch, and Fire8 itself is servicing all of the services. On top of that, configuration, which has different parameters for different components that are specified by service type. We see that there's an aggregate here that has config parameters for the index builder service. There's the other ones for the reader nodes, so it kind of generated a configuration that is adequate for all of the services. So that's regarding the deployment flexibility here. Very quickly, in terms of demo, I'm just going to show what an arbitrum, a value file for deploying the same thing, the same chart, but for the arbitrum chain. So I have If the deployment is still firehose, the default is still kind of the same, one component per one. What are the biggest changes that I had to do to deploy Arbitrum? There's going to be a different tag specific for Arbitrum, and then most of the differences will be happening on the node arguments. Arbitrum Nitro has quite different arguments from Git Ethereum. I'm nulling a lot of parameters that were on the other chart because right now on our canary chart, it's bundling a bunch of default values which are suitable for Ethereum, even though when we release it stable, that won't be the case. And as such, I'm disabling them on this values file. And then I'm adding some Nitro-specific parameters. One interesting part is DOT. On Ethereum, it's called 𝗨𝗂𝗂𝗧. Here, it's just OT. So I need to add them here, and I needed to disable the 𝗨𝗂𝗧 ones here. And then there's also quite a few external dependencies that this chart will require. And this kind of ties to the question raised. For instance, this Arbitrum deployment will need an init mainnet node, and it will need an Arbitrum Classic node. And this does not really scale in terms of making charts have these kinds of dependencies, like you'll be deploying a whole ecosystem to be able to configuration manage all of this in one place. So the way to go there really is on an upper layer, like Launchpad namespaces, and to keep chart scopes to what they are. And this will deploy the same thing. I can maybe quickly do it. Install this. But it's a different image and tune for Arbitrum. Given that we're approaching the end of time, I think I'm going to skip this bit, which would be just asking for deploying this one, and you get kind of the same thing, but with the different parameters. I think you get the idea, and this took a bit. So, very quickly, if there are any questions here. I was talking about why this changes, and we wanted to have the maximum flexibility. And we also wanted to be in a good place to support quite a lot more change and charts, and to do so having a more standardized feature set for our charts and lowering the maintenance burden. And one of the challenges on doing that, as we were interested in developing a library chart and of centralize some of those parts, is that the configuration management was very coupled with the community resources generation, and enabling the values to support templating kind of allows decoupling the configuration logic from that part, which makes it much more feasible. So reducing what each individual chart needs to do, and basically removing the resource part and being able to cut it on a library chart. So that was also one of the goals. And now that we only have a few minutes, if you have any QA, now would be a good time.
Yeah, I just want to flag that. I mean, the GraphHub team has been pretty great in terms of answering the questions as they've come up. So as you've been speaking, they've been getting answered, which is great. But yeah, I mean, if anyone else has any additional questions, now would be a fantastic time to ask them. So far away.
Yes, if not, I'm just gonna very quickly mention. We always talk about a bit about namespaces, also driven by the questions. Launchpad also has task files, which are meant to kind of script common tasks or operations or workflows. And Launchpad Starter, which is more of a skeleton repo for just cloning and serving as a starting point. So kind of the boilerplate to use the Launchpad stack. And I'm going to mention that this firehose chart support is driving this goal of doing library charts, which will be one of the things we'll be bringing next with the other result of standardizing our charts and bringing them up to base with this sort of approach. And also coming next will be focusing more on firehose. So enhancing support for substream sinks, and as I mentioned, kind of supporting a whole lot more chains. Also, thanks to PNX support, as they've been quite collaborative on this as well. I think the slides will be available post. There's a few links here in the end. And if you're interested in trying Launchpad, I'm going to just tell you what your next steps will be. You should join us in Discord. There's a channel there for that, for discussing Launchpads, and we're always around. You should get the Kubernetes cluster. You should clone the Launchpad start repo and just enjoy having access to deploying a very complex fix rather quickly. And just reach out if you're using it. We'd like to hear from you. And we're kind of at time right now. So fire away.
I'm just wondering if InfraDAO is planning on running Firehose anytime soon, and if this would be useful.
Yeah, this is very useful. We will be running it for all non-EVM chains that require Firehose, but we will also be running Firehose for all chains in the future. So definitely very very helpful. Vince will be our main contact on that, on the non-CIP chains, the EVM chains. So I'll defer to him on like exact timing on that. So I was also multitasking a little bit. So if I lost the last 30 seconds, then yeah.
I would just say we're definitely going to be using it in production for the non-EVM chains, and then also utilizing that for substreams if that becomes its own thing and scales out, or whatever else may come. But it's definitely the way to scale. It makes things a lot easier at larger scale. So when we have a lot of chains coming through CIP, this is going to be hugely helpful.
Awesome. So it sounds like very soon there'll be a lot more users, not just us. It'll be good to get it testing.
Yeah, and I don't have a timeline on it, but fairly soon, as we work on charts, PinX will also be, running and testing, and I as well will also be running and testing, the other charts as well, specifically like the RPC charts and everything else that comes with that.
Amazing. Well, anyone have any final questions, thoughts before we wrap? Pili's been so kind as to give everyone the ability to see the presentation. I've linked it right here, and I've also linked to the Kubernetes Launchpad Discord channel, which many of you should go check out if you have any further questions. Oh yes, thank you, Chris, for also linking to the docs. Of course, that's super important to get everything that you need to know in terms of how to familiarize yourself with the software. Cool. Well, we're just over time. If anyone has any burning questions, of course, the floor is always open. But if not, then I'll take this opportunity to say thank you to each and every one of you for joining today's conversation. And yeah, thanks, Chris, for adding these extra links there. Go check them out. And yeah, special thank you to Chris and Anna for leading this. We hope every one of you found this useful. And of course, as I said, the Discord is the best place to reach the entire team. If you have any further questions, of course, the links to the slides and all these other resources are in the Discord chat there. Perfect. Thanks everyone, and we'll see you again, as always, same time next week, for another edition of Index Office Hours.
Thanks everyone.